It may sound crazy, but in the sudden transition to teaching online last semester, I dared to take the leap to implement some changes inspired by physics education research during a time of incredible stress for everyone. I'm pleased to report that it was actually a breath of fresh air for my students and I, giving students decision-making agency to design their own research question increased their engagement at just the right time. In recent years, physics education research has developed a body of revolutionary work that makes it clear it's time to change the way we think about introductory physics lab. The overwhelming challenge of transitioning to teaching online presents a dilemma. Do we invest tremendous effort in translating what we usually do to an online setting, thereby digging in deeper to a traditional way of thinking? Or do we dare learn an entirely different paradigm on top of all the practical challenges that online transitions bring? Because student resistance to reform design choices can be a serious liability, I'll lead by reassuring you that my pivot actually improved my course evaluations. Our introductory physics lab is a 1-hour course which has had a reputation for being arduous for decades. In response to the important question, the professor is successful in creating an environment conducive to learning, the average student rating, for the first time in recent memory, was solidly in agreement. I'm here to share 2 things we added to our course in the online format that were a remarkable improvement. First, giving students agency to not only design an experiment, but to design the research question itself, led to comments such as, "I feel like I learned the most in this lab when we switched to the online learning. That the online part of lab was the most beneficial. It put everything we learned to the test and it was actually enjoyable at the same time, surprisingly enough." A wonderful byproduct of this project-based approach, which happened in small groups via Zoom breakout rooms that I think deserves reflection, is that instructional design of a science lab can create an online space to encourage social belonging during a time when students feel estranged from their peers and professors. A touchstone for all of us should be the 2014 Committee on Labs report, and so I return to that again. In my lab design, I chose to emphasize modeling and quantitatively analyzing data, but weighing on my mind as we approached spring break was that the bottom half of the class tended to memorize analysis recipes, and I was searching for a way to get them to intellectually engaged. It turned out the solution involved adding more from the designing experiments and communicating physics components. I love how this graphic illustrates how these all work together for constructing knowledge. I was grateful to find the curated resources at physport.org for Suddenly Teaching Lab Online, collected by Linda and Sam. They organize under 5 general strategies for how students will perform their measurements from their homes. Students can analyze published data, take measurements from videos, and there are some ideas for making instruments available. What jumped out for me is the Thinking Critically in Physics labs, because I really appreciate the work of Natasha Holmes and colleagues, and I just read their paper on giving students agency. They have shared their complete curriculum, and it's actually very simple to just try it with your students. I had just read this intriguing paper that she wrote with Benjamin Keep and Carl Wieman, in which they say that to learn the processes and practices of science, students must practice scientific decision-making. They convinced me that to make this happen, students need to have more opportunities to make decisions. They define epistemic agency to be opportunities to create knowledge. Decision-making agency includes experimental design, but also developing their own research question. Students are supported by a structure which cues them to make decisions at certain times. The authors note that individual agency encourages individual participation, including for those who may not usually participate, such as due to gender, class, or race. In other words, to connect to my hardest-to-reach students, instead of laboring over more and more detailed instructions, I should back off and cue them to make decisions at strategic times. They reference some interesting work by Bethany Wilcox and Heather Lewandowski on the E-class instrument to measure how expert-like students are in their thinking about experimental physics. We should all take note that their findings are that 20 or so days in a solid traditional physics lab actually leave students with perceptions of experimental physics that are less expert-like, not more expert-like. These 3 studies actually found no measurable benefit in a lecture class from taking lab. I'm convinced that any effort we spend in lab needs to be to incorporate some reforms coming from physics education research. What a daunting task, right? But the easiest thing to do is to simply try a lab written by somebody with deep PER experience, and that's why it was such a relief to try one of Natasha's lab sequences. It turns out that every student actually has a very good magnetometer, their smartphone. In the first week, a sequence of breakout cues is used to put lab groups in separate Zoom breakout rooms to have specific discussions, with a countdown timer shown to keep us all on task. In person, I usually have to ring my no-yell bell a few times to transition from group discussions back to a whole class discussion. My students and I were surprised that the online breakout rooms could actually make this more efficient. By the end of the first lab, students had to choose a magnetic phenomena to measure and had started to develop a research question to investigate. In the second lab, another sequence of breakouts cued students to make scientific decisions to further develop their model. The labs are actually highly structured in this sense, while leaving more decision-making up to the student. Students knew that in week 3 they would be presenting their work to their peers in the form of an online scientific conference. In contrast to laboring to write a big boring lab report for a grade, presenting to a critical audience of their peers created a whole new level of engagement. One student said, "For the first time I actually cared about the answer." I had used Calendly.com to make it easy for students to set up individual or group meetings with me in order to prepare their analyses for the presentations in week 3. They booked 6 hours of time with me. That's never happened before. In hindsight, it makes a lot of sense to design for social belonging in an online lab class. Students visibly appreciated support from their classmates and from me whenever I came into their breakout rooms or in office hours conversations. Several noted appreciation that I was actually more accessible online than in person. In the AIP Team Up report, the first essential factor identified to improve representation of African Americans was fostering a sense of belonging. Whether synchronous or asynchronous, I have become convinced that social belonging needs to be a part of the instructional design of an introductory lab. I had actually been setting up before the transition to online to invite my students to participate in a social belonging intervention. We had a couple brief talks about expecting challenges in university. I illustrated the growth mindset of intelligence concept with a gym analogy. If lifting weights at the gym left you feeling weak, would you decide that you didn't belong there and not go back? I could see smiles and nodding heads from my at-risk students acknowledging receipt. I then asked them to record a letter to a freshman, and here are 2 excerpts.
I'm so thankful that I didn't give up when I wanted to, because I have come so far academically. I actually discovered my new love for science. I want to encourage you to embrace your challenges that you're going to face in undergrad. This will not only help you here and now, but it will help you in the future.
But one of the things that was told to me early on by a mentor and that gave me hope in this time was that even though my classes were going to be harder, my capacity for tackling tougher classes and other challenges would increase. And I can honestly say that that's true. If I were to take general biology now, I'm fully confident that it would not be nearly as hard for me to do well in the class.
This worked so well to give this extra credit assignment to remote students because our online learning platforms made it so simple to collect their videos. And I think that being able to reflect and help other students was meaningful during a time of social isolation and unusual stresses. My takeaway is that the next time I find myself teaching physics lab online, giving students more decision-making agency and tasking them with presenting in an online science conference format can actually make less work for me than trying to micromanage student decisions remotely and laboring over long lab reports, while being more effective for them. I'll also consciously design for social belonging in lab, and I'd like to learn how to do that better. Thank you to Linda, Sam, and Natasha for making such great materials available just when they were urgently needed. Thanks for listening. I hope you found some encouragement to be brave and creative, making the changes you know you need to make to let go of the side of the pool and just swim.